Okay, we're working on the Chapter 8B study guide. And the first question is to graph x equals the log of x minus 2. So remember a few things as you're working on this one. First off, we rewrite using the definition. So it's this base to the outie, which is a y in this case, equals the innie, which is x minus 2. So I'm going to graph this by choosing my y values. Remember that I want to choose y values that give me a nice even 10, right? I don't want fractions and weird numbers. So first off, we're going to use 0. If y is 0, then 10 to the y is 1. 1 plus 2 is 3. I'm going to use 1. If y is 1, 10 to the 1 is 10, plus 2 is 12. Okay, that's very large. So we're going to try minus 1. So that's 1/10 or 0.1. I add 2, I've got 2.1. All right, so let's plot these and see where we're at. X is 3, y is 0. 12, 1 is way the heck off. It's going to be like over here, right? So it's going to be up about there. Okay, but negative 1 is 2.1. Negative 1. Oh, I'm sorry. I was thinking this wrong. Negative 1. So that's about here. Recognize that this x minus 2 means I have an asymptote of x equals 2. Okay, so I'm going to put a dotted line right down that. Okay, so this gives me a good idea of how this graph's going to go. Okay. So what I will be grading on is I will be looking for some points plotted in an XY chart. I will also be looking for the asymptote being drawn on your paper. All right, evaluate log of 1/9. So log base 1/9 of 1/27. So what we're going to do is we're going to find x. We rewrite it using the variable, and then we can just solve for that x, and that makes life easier. So it's the base to the outie, so 1/9 to the x is equal to 1/27. So I have to make these look alike. Now I can make both of these into 1/3 fairly easily. So this is going to be 1/9, oops, not 1/9, 1/3 squared. To the x, so that's to the 2x. And this 27 is 3 cubed. So what I end up with is 2x equals 3. So x equals 3/2. And that's my answer. Okay, convert log log base 3 of 81 equals 4 to exponential formula. That's easy to do. Simply convert using the definition. So it's the base to the outie equals the innie. 3 to the outie equals the innie. Done. Okay. Convert to logarithm. It's the other way. So it's log base, well, the base in this case is 4. So it's the base to the outie equals the innie. There we go. Done. Just remember what it all means. Evaluate log 5 of 125. Now, if I convert this into a 5 with a power, I can eliminate it. My answer is just the power. So this is going to be log. Okay, so now I'm going to do log base 5. Apologies. Log base 5 of 5 to the 3. Well, these cancel because they're inverses, and that leaves me with just 3. So that's my answer. All right, now I come down to 6. Okay, now on this one, okay, I made the mistake of these numbers. Doesn't work out. So we're going to need to change some of these numbers. The 9 has to become an 8. And the 6 has to become a 7. Okay, now what we're going to do is condense these in order to create just a single logarithm on each side. All right, to do that, the pluses become, I multiply what's inside, and then the subtraction, I'll divide, and remember that I am looking for x. Okay, so what I do is I condense. So I have log base 5 of 4x equals log base 5 of 8 times 7 over 2. Because of PEMDAS, I have to do the addition before I do the subtraction. 8 times 7 over 2. So now since what's inside the two logarithms, since they're the same logarithm, log base 5, what's inside I can now set equal to each other. So I now have 4x equals 28. So I divide both sides by 4. X is 7. So my answer is B. Okay. Now, I have to use these values, log A of x and log A of y, to solve log A of the cube root of x over y. First thing I'm going to do is bring that exponent and turn the exponent into a 1/3 instead of a cube root. So this becomes log A x over y to the 1/3. So I can bring that exponent down, 1/3 log A x over y. Now, when I split these apart so I can subtract them, I need to make sure I put that 1/3 on both of them. Log A x minus 1/3 log A y. Okay? Now, I've put these in, and now I'm just going to plug in the values I was given up front. So I have log A x was 0.3, so I have 1/3 times 0.3. Oh dear, this times looks like a multiplication. And this is minus 1/3 times log A of y was 0.9. Well, 1/3 of 0.3 is 0.1. Minus 1/3 of 0.9 is 0.2. Sorry, is 0.3. 0.1 minus 0.3 is a negative 0.2. So my answer is A. 8. All right, again, they're both log. So I can get everything together, do a condensing, and then I can set them equal. So this becomes log x times x plus 3. And this becomes log 2 times 2x plus 1. Now I pull them apart and I set them equal to each other. So I have x, well, this becomes x squared plus 3x. If I multiply the x in, I distribute. And that's equal to 4x plus 2. Again, I distributed the 2 in. So I subtract the 4x. I like my x squared to be positive. And I'm going to have minus x, and I subtract the 2. All right, now I have to factor this. I know you hate that. But as soon as I see a quadratic, I have to factor. So, factors of 2. Hang on. Okay, factors of 2 that subtract to 1. Well, that's going to be 2 and 1. So I have 2 and I have 1. Now, the larger has to be negative. So the 2 is negative. That makes the 1 a positive. So x equals -1 or 2. All right, now, can't be -1. Can't have a negative in the logarithm. And if you notice, up here, x, log x. So, can't have a negative. Can't be log of -1. Okay, so that right there gets rid of the -1. So my answer is x equals 2. Alrighty. And now we're going to move to the next page. All right. Oops, we got to make it bigger. Okay. 9 log 3 of 4x minus 3 plus 3 equals 7. Okay, so we have to solve. Whoops, sorry about that. I meant to change that to highlighting. Solve for x. So I have to get it out. Best way I know is isolate that log base 3 and then use our definition since I don't have logs on both sides. Okay, so I've got to subtract the 3. That's how I'm isolating. So I'm going to have log base 3 of 4x minus 3 is equal to 4. 7 minus 3. Now I use my definition. The base to the outie equals the innie. Okay, so now what is 3 to the 4? 81. I'm going to add 3 to both sides, and I'm left with 4x. Well, now I have 84, and I'm going to divide both sides by 4 to give me x. Well, half of 84 is 42, half of that is 21, so 21 is x. So my answer is D. 10. Solve for to the 5x equals 3. Okay, so I have to take the log in order to get that 5x out of there. So if I do log 4 to the 5x is equal to log 3. Take this log of both sides. I can bring the 5x down since it's an exponent. Divide both sides by log 4. This is not the log of 3/4. This is log 3 divided by log 4. Very different numbers. So now I have 5x equals log 3 over log 4. But when I divide by 5, I gain a 5 here on the bottom. So x is equal to log 3 over 5 log 4. I can put this in my calculator. And I have log 3, close parenthesis, divided by 5. Oops, this has to be in parentheses. 5 times... If you don't put that denominator in parentheses, you're going to get a whole different number. Let me show you in a second. Log, I'm just going to do this. And I should get 0.158 to the nearest 10,000. That's 4 decimal places. 585. 5. So that should be my answer. What I was saying is if I don't put this in parentheses when I plug it into my calculator, what I'll end up getting is log 3 over 5, and then all of that times log 4. No, that is not what I want. Okay, so what you have in your calculator is log, it does this, then you do 3. Log 3, close your parenthesis. Okay, actually what I'm going to do is, now that I think about it, I will write in red what you type in aside from the log. And then divide, and then you're going to have parenthesis 5 log 4 close. That's what's going to give you your answer. 0.1585. All right, number 11. All right, again, we've got to condense. So we have log base 3 of x times x minus 6 equals 3. Now we do our definition. Since I have log on only one side, definition. Base to the outie equals the innie. This is 27, so I subtract that. Okay, now I've got a quadratic, I factor. Okay, let's do it this way. Factors of 27 that subtract to 6. All right, so let's see. 27 is 9 times 3. That does it. 9 and 3. The largest is negative, so the 9 has to be the negative. So I have a minus 9 and a plus 3. So this means I have x equals 9 or negative 3. All right, since I started out with a log base 3 of x, negative 3 can't be it. That's extraneous. I have to double check this one. If x is 9, will I have a negative number? No. So x is 9 is fine. So my answer is x equals 9. Oh, sorry. Next side. All right, now, would it be better to invest at 7.2% compounded annually or 6.9% compounded continuously? Okay, so what we're going to do is we're going to say, all right, which is greater? This A, which is going to be equal to whatever my principal is, times plus, since it's compounded annually, it's straight up the interest, 0.072. If it was semi-annually, you would have something down here. But since it's annual, you don't have it. If it was semi-annual, that would be a 2. Okay, but it's not, so we're going to erase that. To the rate to the t. So this is assuming 1 year. What I need to do, look at, is if t is just 1 year, that becomes to the 1. And if I'm looking at the other equation, notice it's basically this, compounded continuously is PERT. Sorry. So that would be PE to the rate, which is 0.069 times 1. So really what I have to look at is this part in here is 1.072. Is e to the 0.69 larger? So I'm going to put that into my calculator. So I have e to the 0.069, and I get 1.0714. Well, no, this is actually smaller. So really, the 7.2 gives me better interest rate. So that means A. All right, so now we're doing a natural log. All right, so this gives me natural log of 2x minus 1 is equal to 4 over 3, because all I did was divide both sides by 3. All right, now I can do base to the outie equals the innie. So my base for this is e. So e to the 4/3, base to the outie, is equal to 2x minus 1. Now I'm solving for x. So I add 1. Well, now I divide by 2 to get x. Now remember, I'm dividing this whole thing, so I'm going to put parentheses around it. So I have parentheses, second natural log gives me e to the x, 4 divide 3, side arrow to get out of the exponent, plus 1, close the parentheses, divided by 2. And I get 2.3, 3 decimal places, 97. 2.397 is my answer. $2.397. Okay. Now, how long will it take compounded continuously? So this is my PERT again. All right, so how long will it take 9,000 to grow to? That's my A, and that's my P. So 54,000 equals 9,000. E to the R I know is 6%, so that's 0.06. T is what I'm looking for. Now, since T is in my exponent, I'm going to have to eventually use a natural log. Okay, so or some kind of log. So what I'm going to do is, first, I am dividing by 9,000. So this gives me 6 equals e to the 0.06 t. Well, I have to take now I have to take log of both sides. Log of 6 is equal to log of e to the 0.06 t. You can bring the 0.06 t down front. Log 6 equals 0.06 t log of e. Okay, so now I divide both sides by 0.06 log e. All right, and if I put this into my calculator, I'm left with t. So remember that you're going to have parentheses here. You have to have parentheses around the whole thing in the denominator. So log 6, close parenthesis, divided by open parenthesis, 0.06 times log e. Remember, e is second divide, close parenthesis. And I get t equals 29.86 years. So approximately 30 years. And that's your 14. And that's the last one. Okay, and we're done. Whoa.